One of the ways that right triangles are used a lot in real life are through angles of elevation and depression. So what is an angle of elevation? It's the angle that is formed by a horizontal line and the line of sight. So if you've got to be looking up. So whatever this angle right here, and it's funny because it's the angle that's on the bottom of the picture, but who's looking up, the person on bottom or the person on top? So it's the horizontal line and the line of sight. So I'm calling the line of sight what connects the person that's looking and the thing being looked at. And so this angle right here is the angle of elevation. The angle of depression is from the other vantage point, so you're looking down. So you have the horizontal line, instead of going up, you're going down. So your horizontal line's on top, and it's this angle between the horizontal and the line of sight. And the angle of depression is always at the top of the picture because the person who's looking down is at the top of the picture. All right. So we're going to go ahead and look at this picture here, and we have a person at point C, and then we have a person at point A up at the Round Rock Water Tower. And is angle CAD, is that an angle of elevation? Is it an angle of depression, or neither? Well, is that angle being made with a horizontal line? No. So it's neither. Automatically, you don't even have to think about it. Now let's look at angle CAB. Is there a horizontal line? Yes, there is. From that horizontal line, is the person looking down or up? They're looking down. So this is an angle of depression. Angle ACB, is there a horizontal line for that angle? No. So neither. ACD, is there a horizontal line here? Yes, there is. And the person at that angle, are they looking up or down? They're looking up. So that's an angle of elevation. So the cool thing about the relationship between the two angles, let me go back here, since these horizontal lines are always parallel, and you have a transversal here, the two blue angles will always be congruent because they're alternate interior angles, which means that the angle of elevation is always congruent to the angle of depression because both are alternate interior angles. So some problem-solving strategies. Draw a picture. A lot of your problems will not have pictures. You'll have to draw them. Label the known sides and or angles. Label the unknown side or angle with a variable. And label the angles of elevation and depression. Remember, they're always the same. Set up an equation using a known triangle. So we're going to be doing special rights right now, but later we're going to be using trigonometric ratios. So in this example, D is flying a kite. The length of the kite string is 50 yards. D sees that the angle of elevation from her to the kite is 60 degrees. So here's a picture I drew. And D's down here at the bottom. And remember, angle of elevation is from the person looking up. So this is the angle of elevation. 50 yards, that's a kite string. And what is the angle of depression? Well, remember, I actually don't even have to draw the angle of depression. Remember, they're always congruent, so I can automatically say it's 60 degrees. Now, what is the horizontal distance from D to the kite? Well, I'm going to go ahead and set up a triangle. First of all, this is the horizontal distance, this horizontal line. And I'm going to use a similar triangle. I see the 60 degrees there. So that makes me think of the 30, 60, 90. So I took the triangle from the math chart and I rotated it so it's in the same orientation. Now I'm going to go ahead and replace those darn x's with 1's, and I have a 1, 2, square root of 3. Notice the 2 is the hypotenuse, not the square root of 3. Square root of 3 is about 1.7, so it's not bigger than 2. All right, so I'm going to go ahead and label this side x. And we'll go ahead and set up a proportion. 50 over x equals 2 over 1. So this is a pretty simple cross-multiplying proportion. 50 equals 2x. Divide by 2. So x is 25. So I can say that's 25 right here. Now I'm going to find the vertical distance. And so I'll do a proportion again. I'm going to actually use the one side, this x side. So instead of putting x, I put 25. So y over 25 equals square root of 3 over 1. Cross multiply and I get y equals 25 square root of 3. For those of you who may be looking for a shortcut, do you see, if I knew this part right here, let me go ahead and get my pen. If I knew this was 25 down here, and I know this is 1, and I get square root of 3 up here, do you see how I can get from 25 to 25 square root of 3 there? All right, and actually I'm going to leave it in the exact answers. We can go ahead and round in class. I'm actually more interested in exact answers than decimal answers when possible. Now we have an airplane flying at an altitude of 3,000 meters, and the distance from you directly to the airplane is 6,000 meters. Altitude means vertical distance, so straight up and down. The distance directly, it's like you connect the two objects with a piece of string, however long that string would be. So let me go ahead and draw a picture, and you can see it's like I'm flying an airplane. So I have this distance directly between me and the airplane is 6,000 meters. The vertical distance, or the altitude, is 3,000 meters. Now, this is an interesting problem, not normally one you're going to encounter, but I'm asking what is the angle of elevation. So what I'm asking you to do is to recognize this triangle. The hypotenuse is 6,000 and one of the legs is 3,000. Let me simplify that. That's like the hypotenuse being 2 and one of the legs being 1. Do we know any right triangles that behave that way? Well, we do. It's a 30, 60, 90. Let me go ahead and put in my 1's instead of x's. And you can see it has a hypotenuse of 2 and a leg of 1. And then the other leg is square root of 3. So what I'm going to do is find that horizontal, and since it's a 30, 60, 90, that tells me that that 30 degrees goes in the corresponding angle. That's the angle of elevation. Now, I don't have the angle of depression drawn. It would actually be like I draw a horizontal here in that little angle. But since it's an alternate interior angle, it's congruent. So I know it's 30 degrees as well. So what is the horizontal distance? I'm going to put an x there, and we'll go ahead and set up a proportion with those two sides. I like the one side whenever I can use it because the math is easier. So 3,000 over x is 1 over square root of 3. You multiply, cross multiply, and you get 1 times x is x, and 3,000 square root of 3. Now this does say to the nearest meter, and I didn't do it here. I actually gave you an exact answer. So for further reflection, how can you tell if the distance is on the hypotenuse or one of the legs of the triangle? Vertical distance is going to be a leg. Horizontal distance is going to be a leg. Hypotenuse will be the distance directly between the two objects. What is vertical distance? Straight up and down. What is horizontal distance? The flat one.